Welcome to This Week in Health IT, where we discuss the news, information, and emerging thought with leaders from across the healthcare industry. My name is Bill Russell, recovering healthcare CIO and creator of This Week in Health IT, a set of podcasts and videos dedicated to training the next generation of health IT leaders. Today, healthcare needs more data scientists. We take a look at the path to becoming a clinical data scientist. This podcast is brought to you by Health Lyrics. Looking for someone to be your personal coach in healthcare technology? Let's talk. Visit healthlyrics.com to schedule your free consultation. Our guest today is Charles Boicey, MS, RN, BC, lots of acronyms by his name, Chief Innovation Officer for Clearsense and Assistant Clinical Professor at Stony Brook University. Good afternoon, Charles. Welcome to the show.
Hey, Bill. Thanks for having me.
Well, I love having you on the show. We don't do it enough because you're all over, literally all over the world. The last time I tried to have you on the show, you were in India, and next week you're going to be in Cleveland. You're literally all over the world. It's kind of hard to track you down. But we ran into each other at HIMSS, and we started talking about this topic of data scientists and clinical data scientists. And I got kind of excited about having you on to talk to this specific subject, because there's so many doctors and nurses who are saying, hey, I see the need. I see the need to really turn data into insights and into things that can be used to effectively drive down the cost of healthcare, improve access, and better experience, better outcomes, and they get excited about it. And so I thought it would be great to just have you and I talk about what does that path look like for them to go from practicing physician or practicing clinician to the data scientist role, and that's what we're going to try to do today.
Sure. So let's kind of start off with something that probably people don't think about, and they should. Really, what is a data scientist? What is that all about? And I'm not going to get into what degrees, what certifications. I'm not going to get into any of that. At the end, we'll talk about some programs that are out there that can help you get to that point. But I really want to kind of go over initially what is a data scientist? What are the three domains, if you will, that constitute a data scientist? What do you need, et cetera? And the three domains are subject matter expertise, computer science,
which they have the subject matter expertise, and then domain science domain expertise in computer science, and then what's the third?
The third one is math, stats, mathematics skills, critical thinking skills.
Yeah. So we're going to dive into those, but here's the thing I know about the two of us. We get excited and we get going. So we needed sort of a framework to keep us from going off on the tangents we usually do.
Absolutely.
So the first thing I want to do is, so there's three movements we're going to do on this show. First is current state of data science and what is data science. The second movement is going to be a typical data science project in healthcare and what the process looks like. Because I think some people think data science and they think the report writers or the people who are doing the reports. And that's, we'll call that like the beginner, but that isn't really data science. And we'll talk about what a project looks like. And I think that will open people's eyes to what's possible. And then the third movement is going to be the path of becoming a clinical data scientist. And we'll talk about the different programs and whatnot.
Sounds good.
So let's start with current state of data science in healthcare. So you're doing a lot of things. What is, I don't even know how to frame this question other than to say, broad question, current state, what is it?
Current state of data science is we're jumping into it and we're doing as much as we can, as fast as we can. Basically we've jumped on the horse and we're charging off wildly in all directions.
So people recognize the need for it, but they don't know what direction to point it in yet. Or are they finding ways to do it and they're sort of experimenting in a lot of different areas?
Well, just like anything, even bringing in, data visualization and analytics as we did, there's some that are at a higher maturity level than others. And what's really good is it's been recognized, it's legitimized. Many organizations have legitimized, data science and the application of, data science products. So that's the good news. The not so good news is it's still the wild, wild west. There's still a lot of organizations that are hiring folks really without a problem to solve. I want to get into data science. I want to do predictive analytics. Let's hire a team. It's kind of like the religious movement of data governance a few years back. We all know what that looked like.
Yeah, and you're like smacking me around here because I am one of those people who hired 3 data scientists. I put them in a group, and I said, all right, you know, we're gonna, and they were like, oh, we know what to do. And I checked back on them 6 months later, and they were writing reports, and they were buried in places of the organization. And I realized you really do have to lead this. And so, what does it look like what does a leading health system look like that is applying data science today?
Sure. So that is the key word that you said was applied. They understand that there is a need to apply that which is, you know, the products that are, you know, developed in a data science program. They actually have they actually have a program in place. You remember when we started with the 30-day readmissions? You know, can you predict 30-day readmits? The first question that I asked when I was asked that, I said, yeah, absolutely. But do you have a program in place to address those patients that we discover that are likely to readmit? Because if you don't, we've got a problem. We've got an ethical problem. We've identified people that we're not going to be able to take care of. And then, you know, secondary to that, we've just performed a statistical exercise. I'll predict them. We'll see if they readmit, and we'll just keep some stats. So you really, really have to think this thing through. And you have to have a plan in place, and you have to have, you know, objectives, you know, clear objectives. You know, why are you doing this? Not just because, you know, my healthcare organization neighbor down the street now has a data scientist. I want one too.
Yeah, I mean, you make a good point there. So I was talking to a CIO, and we were talking about in the consumer area how the chief digital officer, the CIO, the ops, the COO, and the chief strategy officer need to almost be tied at the hip, because one begets another begets another. I mean, they're also so closely linked. But in the data science world, the same thing's true in terms of operations. Everything you're going to be analyzing is going to kick off something. You're going to find something out, and it's like, all right, now what do we do? We know the people that are going to readmit. We got to put a program together.
Yeah, so it covers operations, it covers clinical practice, it covers finance, and if the organization happens to be tied to research, you have a research component of it as well. And you're absolutely right; they all have to be, you know, tied at the hip.
Where does this typically report? I've heard this. I do a fair amount of consulting still, and we had this problem where I was the CIO. Analytics was everywhere, right? And it should be everywhere. It should be close to where it can be applied. But from a reporting standpoint, it literally was everywhere. And we went through the organization and looked at everybody with a title of analyst, which is typically how they hide people within a budget. And we found 180 of them or something like that. Didn't report into IT. They were just data analysts of some kind, and they were all over the place. You know, what does a good program look like? Where does this report into? You know, what's the matrix? What's the dotted line? And then how do they ensure quality throughout the organization?
Sure. So an organization that's mature, that you know, gets it, that you know is where they need to be. I usually see these teams, you know, reporting through the chief data officer, to be honest with you, or the chief analytics officer. And these are, you know, if they're not at the end of maturity, you know, somewhere at a midpoint, they have their data needs taken care of. And what I mean by that, there is a central repository or platform, if you will, that these types of activities can occur in. And you know, it's really interesting, Bill, because these types of organizations also have decentralized, you know, analytics and whatnot. That's great to have at the department level, but they're all working off the same data sources and whatnot because they've gotten to the point where it is absolutely centralized. And I say that because data scientists, if they're spending 80% of their time data wrangling, you're not using them correctly. You're not using them wisely. They should spend their time actually, you know, applying data science to the data because the environment is such that they can do that. But usually if there is not a chief data officer, this is something that as you know, the CIO needs to keep keep tabs on, because it can, go out of control pretty quick.
Yeah, that's one of the conclusions we came to, is that the IT function was going to be the data wrangling. It was going to be the interoperability, pulling all the data together and providing the tools, and helping to establish the dictionary. What does the terminology mean? Because that's the other big problem you end up with, is people generating insights, and it's based off of data that may or may not have the definition they thought it had.
Yeah, sure. So the ideal state for a data science team is absolutely to have that governance in place, to have that catalog in place, to have things such as length of stay defined for the entire organization, and that could be multiple hospital entities and whatnot. So you're absolutely correct.
So let's talk about a typical data science project. I mean, you used readmissions. I don't know if you want to use another one, but
no, yeah, I'll use another one that's that I think is an important one. Let's look at, we'll use two of them. We can talk about two because some of the elements are pretty similar. Let's look at it in a couple of levels. So let's say somebody came to me and said, hey Charles, we'd like you to develop a predictive model for predicting patients that are likely to become hypertensive, or let's say likely to become type 2 diabetics. That's reasonable. But I would push back and say, hey, let's do that, but let's start here first. Let's find those patients within our population that are undiagnosed diabetics or undiagnosed hypertensive patients. We all have them. So that would be step one for me. Step two would be the predictive model, because I, as a clinician, I want to help as many people as I can, quicker. And that's one of the benefits of having a clinician data scientist, because they got the domain. They totally understand the domain, and they would come to something similar to that. So so what do we do? What does that look like? Really, first step is what I call business understanding, if you will. Really, what are the defined objectives? What are the data sources that we need? And let's do some research. I'm not going to be the first one to build a model for those two items. I'm sure a lot of work has been done prior to me. So let's find out the work that's been done. Let's do the research, and then let's start bringing in the data that's required for that. So let's bring in the data, explore the data, get the data quality, work all the kinks out there. And then at that point, we've got what we want to do. We've got the data that we need to do it in. And now we do what's called feature selection.
All right. So in the business understanding, so you have you're going to define the objectives. You're going to identify the data sources, and then you're going to do some research. Where would you go for the research? I mean, do you go to?
Sure. This is PubMed for our purposes, being in healthcare.
Yeah.
This is peer-reviewed, journals and so forth. It's really important. Google search in this case usually doesn't cut it, although you might find a few things that are valid. But again, PubMed and some of the peer-reviewed journals and whatnot, just to kind of get a flavor of what's gone on before you. And to be honest with you, it actually kickstarts and gets you thinking. A lot of data science is really about having that self-talk, or if you will, that cognitive exercise of what we're really trying to do and whatnot. And that's why clinicians doing this have the discipline and understanding of certain features that are likely. I'm going to put some likely, emphasize that, that'll be of benefit in a model like this. But there's also other data elements out there that we need to look at, such as social determinants, exposome data, other data elements within the healthcare data set, if you will, that play a role in that. So we're now doing the modeling. We're doing feature selection. I'm oversimplifying this, Bill, because
well, you almost have to. I mean, because at this point you've done your research, but then you have to get the data. Now in a mature organization, that data is going to be just available to you either in an EDW or accessible through a big data platform or set of APIs. But generally, there's an awful lot of work that goes on there of wrangling that data and cleaning it up, I would assume.
Yes. So in that case, again, remember I told you don't want your data science guy to, or gal to be, doing data wrangling.
Right.
So that's where a data engineer or a data wrangler would come into play. Data scientist says, "Hey, this is what I need." Data wrangler goes up and wrangles it up, if you will, and delivers it to the data scientist so that they have a data set that they can start working with.
So they'll spend a lot of time in business understanding, hopefully very little in the data ingestion and acquisition. And then they spend, I assume the data scientist spends a fair amount of time in the modeling.
Yes.
And that's where they're earning their keep, really, I would think.
Yeah, that's their training. That's their, that's their discipline. That's their gig. That's what they do.
And do you start, I mean, this is one of the things that somebody had said to me is, do you start with the hypothesis or do you start with the data? And the data sort of tells a story.
I am the a priori approach, which is let the data speak for itself. Others have the other approach. Neither one is wrong, but one should consider, the other. Let's say a diabetic model. I'd be foolish if I left out A1Cs, right? That would make absolutely zero sense to me. Or a BMI calculation. So there are some features that we know that are going to play a role, but let's look at the rest of the data and see what comes up with it. And tools such as linear regression and so forth will help us understand that. The benefit that we have in healthcare is we have diabetic type 2 patients. We have we have hypertensive patients. And if we get into predictive models for patients that are likely to crash, we have all of that. So, understanding those patients, those data sets, those features and whatnot are of an absolute benefit for the design. And then considering, features outside, social determinants. I get a big boost personally in accuracy by using certain social determinants of health within these predictive models, especially for patients likely to become diabetic and hypertensive and so forth. So you got to kind of take it from, all aspects. And then you've got to have the discipline. Hey, if I come up with a model that's, 0.5, well, that's a flip of a coin. That's really not going to, do me any good. This is where data science in the training and the rigor around it really comes into play. You have to be disciplined to say, okay, this model isn't working. It doesn't have the accuracy that I'm looking for. I got to go on to something else, right? And I'll experiment. I'll do what I need to do. I'll maybe do an ensemble model. But at the end of the day, if my accuracy is not such that it's going to work, then I've got to call it at that point. I'm not going to go bend features and do manipulations and so forth so that I get an area under the curve that's in the high 90s. It is what it is. Maybe in some models, 0.75 will be acceptable, and others maybe 0.88 to 0.9 will be acceptable. And that's where the communication comes in, Bill. Everybody that's involved in one of these projects has to be there for all of this. None of this can be black boxed. They have to see the data sets. They have to see the feature selection. They have to see the math. They have to see the output and whatnot. That's the only way you're going to get buy-in as well.
All right. So just a little tangent, just because you said that.
Sure.
We've been talking a lot about AI recently on the show, and we've talked to different people about AI. And one of the things is, you have these vendors who come in and say, well, we have these algorithms, and they're sort of behind the curtain. And it sounds like what you're saying is there's no such thing as behind the curtain when you're talking about clinical efficacy within clinical environments. So they almost have to reveal some of the algorithms, how the math is done, and how they come up with their findings. Otherwise, it's going to be really hard for us to just implement some of these things within the clinical environment.
Yeah, absolutely. And I'm going to tell you that a certain model in Irvine, California, may not be applicable in Sarasota, Florida, in a healthcare organization that the predominance of patients is 65 and above. These models have to fit the population, and that's kind of where we go awry kind of in healthcare, where a lot of our best practices and models and so forth were built on a population that may or may not still exist, or not exist in the geolocation that we're going to try to apply it. And this is not a one and done. As we go through the process, yeah, we have to operationalize it, but there's a lot more than operationalizing. We got to continue to test and validate. You can't just dump the black box off at the door, walk away from it. You got to be really monitoring that over time. Not only is it accurate, but for crying out loud, did it actually affect any change? Was anybody paying attention to it? So these products not in a workflow, there's going to be some issues there, especially on the adoption side.
So when it goes into when you're operationalizing it, the data scientist is still pretty heavily involved in terms of testing, validation, and keeping making sure that that the model is working out the way that everyone expects it to work out. I mean, their job is to sort of act as the scorekeeper and say, hey, the model's still holding, the results are good, and those kind of things. I mean, am I seeing that right, or am I saying that?
Yeah, absolutely. So let's take the diabetes or the hypertension. Did those patients that were identified, in fact, become hypertensive? Or even looking at patient deterioration type models, every month looking at the rapid response team responses, looking at the code blues and so forth, and actually going back to the algorithm and whatnot. Were these scored? Did anybody take action on it? Did we miss anything? What were our false positive? What were our false negatives? Yeah, this is something that you really have to pay a good bit of attention to ongoing, especially in the first stages of deployment and whatnot. But you've got to go back and look at this stuff.
Now, so does a data scientist handle like 2 or 3 of these kinds of projects at the same time, or are they typically focused in on one?
Sure. So my personal is I like to do one. There are folks that can do 2 or more at a given time. That's okay when you're kind of doing the data wrangling and whatnot. But when you really have to be concentrated and focused, for me, I really have to be into that one until I get to the conclusion of I've got a model that I feel is fit and ready for deployment.
And you can justify that cost, and I've had this conversation with executives. You can justify that cost because some of the outcomes dramatically improve outcomes or dramatically improve efficiencies to the point where you're freeing up millions of dollars, and you're keeping people healthy. And I mean, there's significant benefits from these projects generally.
There's significant benefit from the project. There's not single benefits from hiring individuals, because if you don't have that complete program in place, then I don't care how many accurate models you've built. If they're not deployed properly, if they're not, I won't reiterate it, but you get the picture.
Yeah, you get the picture. I mean, the system has to have the ability to act on the data once they see the data. All right, so let's take a look at becoming a clinical data scientist. We've had a couple shows now where people have talked about the fact, I mean, Lee Milligan's been on the show, and he's a physician who became a CMIO, who's now become a CIO, who now oversees their data practice. And we're seeing a lot of clinicians move in this direction. What does that look like? What does it look like for a clinician? Do they generally, I mean, for Lee, the path was, essentially, somebody who really understood the data and understood the EMR. And then they said, hey, why don't you become the CMIO and help us to implement this? He implemented it. And then he became, hey, we'll put you over analytics because you seem to get analytics. And then he just kept learning and growing into the role. Do you see that? I mean, is that generally what has happened? And do you see that transforming into a more disciplined path where people actually get degrees and move into it?
Sure. So a couple of things. One, that was an organic progression. That's, my story as well, really. It happened organically. When I talk to clinicians now, the first thing I asked them a question: are you running from something, or are you running to something? Because if you're running from something, this probably isn't going to work for you. But if you're running to it because you really want to embrace it, then, let's keep talking. So, kind of the pathway, the domain knowledge is there. You can be a physician assistant, you can be a nurse practitioner, pharmacist, dietitian, physician, clinician. You have that domain knowledge. You know how a hospital works, you know how the ambulatory environment works. You absolutely have that. That's gold. That is, that will get you a majority of the way there. A lot of the tools we use are based on having some programming knowledge. So you got Python, you've got R. There's a few others out there. You have to be able to, amp those skills up. And on the math side, we're all pretty well versed in that. If you think about, clinicians' education, pretty good with math, pretty good on the statistics side. Yes, there'll be a need to brush up on that. But I would say that the computer science side is really the area that we need the most focus on. There's some pretty good programs, Bill, that you can audit within the Coursera environment. And that's where I would start. And the reason I say that to folks is before you start, spending, tuition dollars and so forth, take a look at, what you're getting involved in. And so you can make a really good choice, based on your interest and so forth. This isn't going to be something that you can, jump in. It's not going to be easy. It's going to take some discipline and rigor. But, the transition is absolutely there. And I'm not going to get into the, MS versus PhD argument, okay? Because that could be a whole nother show. And, I may not do the benefit of both. I will say that those that have gone through a doctoral program have a pretty good sense of rigor, and that is beneficial in this kind of environment. The last thing you want are models that were created to get to a certain goal, as opposed to it is what it is. You know what I mean?
Yeah. It's interesting to me that you say R and Python, because for people who feel like programming languages change very rapidly, and I'm going to have to learn something new in 3 to 5 years. The R and Python have been the sort of bedrock for this for, well, as long as I can remember. I mean,
yeah, in the last year and a half or so, Python has actually eclipsed R, and for the clinician, that's pretty cool, because Python is more of a language, natural language, if you will, where R has a little bit more programming language to it. There's a little bit more, syntax that's learned. Again, I'm at Stony Brook University, and I flipped my data science program to center around a Python now. I do teach a little bit of R, but it's primarily Python driven, and the students have had better success within the Python environment.
And my son's at one of the big 4 firms, and they required them to learn Python, because it's now becoming one of those things. If you're going through a computer science program at a college or university, I would assume you're going to be picking up Python as a language, as opposed to when you and I would have gone through it. It was it was C, and it was BASIC and some other crazy things. But there's data science programs springing up all over the place, and why don't you talk a little bit about those, and then you and Clearsense were involved in one I think that's pretty interesting. Give us an idea of what those programs look like.
Sure. So you've got a complete master's program. You've got a PhD route as well. Many clinicians, are at the BS or MS or PhD level. So pick your entry point. There's also some really good certificate programs. I would stay with organizations that are academic medical centers. I'm not going to name names, but there are several, and they are the ones that are really. You want one that's focused in healthcare. You really don't want one that's focused outside of healthcare, because it doesn't really make any sense. You're going to do a hell of a lot of adapting the curriculum to meet your needs. I would definitely do that Coursera thing for audit purposes, and then make the decision whether you want to do the certificate program. in, from that, MS or PhD. You know, healthcare is employing data scientists, and there's two things that are happening. One, organizations are hiring folks not knowing what a data scientist really needs to do or what one really is. And then 6 months later, they find out that they didn't hire what they thought they hired. So really all that front work and putting the program in place is really, really essential. And then the other is hiring data scientists from domains outside of healthcare. And you just have to work with them and put a data wrangler or an informaticist alongside of them to work side by side, because they can go off in weird tangents, if you will, because of not having the domain knowledge.
So let's talk about that. So I'm going to build that out. I'm going to build the program out within my system. Am I better off taking some clinicians and putting them next to taking some clinicians and getting them the skills they need to start to play with the data? Or am I better off bringing in data scientists and matching them with clinicians? I mean, which tends to work better?
What have I seen that's been the ideal? You've got some really good clinician data wranglers. You've got some nurse informaticists on your team. Many of us have. Marrying them up with a data scientist from outside of healthcare will do two things. That knowledge transfer of domain will absolutely occur. What's I don't know, maybe more important, that spark of working with a data scientist and seeing what can be done, with the data will absolutely occur, and that'll propel, that clinician to, further along their, training and studies and whatnot. That's what I've experienced, and that's what I've seen that's worked, worked really well.
I mean, there's a lot of exciting things in healthcare. I love the cloud because it brings new levels of efficiency. Consumer trends are going to, really help take the friction out of healthcare, and I think that's exciting. IoT is going to allow us to reach beyond our walls, but data clearly has the ability to transform healthcare if applied correctly in the right places. It's one of the things that is going to affect outcomes, cost, quality, access, experience. It can impact all aspects, and in order to do that effectively, an organization, I feel like, and this is the message that we're really trying to get out there. An organization has to say, we have to be we can be a B in infrastructure, we can be a B in some other things, but we have to be an A in our use of data. And what you're seeing out there is health systems are going to start to differentiate themselves on the ability to use data. And you're starting to see some of those articles where the headline will read, they impacted this outcome, or they impacted this these financial metrics or whatnot, and you could see some distance starting to generate or to separate these. And I think that the use of data, much more so than some of these other skills, is really going to be the driver. I mean, that's been my experiences, and I assume that's your experience as well.
Yeah, and it both from an operation financial perspective, it's survivability and sustainability. 2 letters, MA. You're going to become an acquisition if you're not, if you don't have this skill set. And we can't fly operationally and financially by the seat of our pants anymore. It's not working out well. And you're subject to being acquired. And on the clinical side, this application of data science, I look at it from an intelligent assist perspective. Hey, we're not telling anybody what to do. We're really assisting you, right? These are the patients that we found in your population that are likely undiagnosed hypertensive patients and/or diabetic patients. Hey, let's take a look at them. These are the ones that are likely to. These are the patients that are likely to deteriorate. These are patients that are likely to enter a sepsis pathway. Again, using this technology to help, not to beat somebody up over the head or tell them what to do or to say you have to do this therapy, that therapy, really, but just kind of being their eyes and ears out there for them. And machines do a great job of that. So
yeah, absolutely. Yeah. Well, Charles, always great to have you on the show. Is there an easy way for people to follow you on social media?
Sure. The Twitter handle is N2Informatics RN, and that pretty much covers it.
One of the other things I wanted to touch on, but we do have a bunch of college professors and people within academic institutions following the show. Those who are interested in developing this kind of program are those the kind of people that you generally have conversations with on what they would do to develop a program at their college or university?
Yeah, and I've helped several do it. Meharry Medical College, just briefly, we now have a program in place where their medical students, when they graduate this July, they'll graduate with a certificate in data science. The next couple of classes, MS, and then 3 years out, we're looking at a PhD program. So basically physician data scientists. And I have helped, Georgetown, I've helped other organizations with their curriculum and whatnot. I'd be more than happy to help an organization with that. And again, my stance on this is of an applied nature, a little bit of theory, but a lot of application, which is, kind of my thing. I'd rather apply it than talk about, what we could do. You know what I mean?
Yep. And my two people to talk to whenever that comes up is you and Dale Sanders, because I think you two are
Absolutely.
very focused on making stuff happen. So
yeah, he's the guy. Absolutely.
Absolutely. So I appreciate you coming on the show. This show is a production of This Week in Health IT. For more great content, check out the website at thisweekinhealthit.com or the YouTube channel at thisweekinhealthit.com/video. Thanks for listening. That's all for now.